Okay, statics lovers, we have an interesting challenge here, and that is that you get a first real use of calculus in your statics course. The problem, of course, is that calculus isn't always so easy, right? And the kind of context that we're talking about is we have maybe a concrete dam, and we want to know where its center of mass or centroid of the area is. We also are you're eventually going to find out, care a lot about this water behind the dam in this little segment that is directly above this upstream dam surface and where its centroid is at. And these are not so easy to do by discrete approaches, but calculus approaches actually make this a tractable problem. But that does raise some challenges here. So let's go back and review real quickly. And that is that when you're finding first moments of area, then for the discrete version, then that means recognizable geometric shapes. Then we can do it like this, that Q would be equal to the sum of x bar of each piece times a of each piece. That would be, of course, for the first moment with respect to the y-axis. For the x-axis, we just swap roles here. That would be your discrete version. But for the continuous version, we're going to use then calculus. Now, I'll write the equation and then we'll come back and show all the little pieces together to make this all sort of make more sense. Right? So for QY, it's going to be the same kind of thing, but instead of summation, we're going to now take some centroidal distance of some differential strip, right, from the distance from the y-axis times the differential area and add them all up. But that's the continuous version, means integration. Right? So I really just kind of swapped subscripts. X bar, the bar over the x makes me think of discrete things. X sub c is a distance to a differential strip. They're really the same things, but sometimes people like to use different symbols, as I did here. Right, so that's what the first moment looks like. Now when we find the centroidal distance, it's all the same deal, right? That x bar is equal to q sub y over a, and y bar is equal to q sub x over a. It's the same overall formula, whether it's continuous or discrete. How we find the first moments is what's going to change. So let's go and have some sort of graphic understanding of what's happening here. And since we've got a parabola there, I'm going to show a parabola in a slightly different form than what we have on with that dam, and that is I'm going to show it with the vertex down here at the bottom left and then coming up, right? And so we'll call that 0, and this is a out here, and this height we'll call h. In this equation is y equals kx squared. You'll see in another example why I use that specific one, but it's just a parabola here, and that part isn't so crucial. What's crucial is I've decided to do a differential strip, which was easy to define, and that would be a vertical one, where we've got the base at dx, and the height is, well, it's y. Now, the centroid of a little rectangle is, of course, at mid-height. Since the height is y, then the centroid, or y sub c, is equal to y divided by 2. Y is equal to kx squared. So you'd end up with y sub c looking like this. So this expression for qx, first moment with respect to the x-axis, then this integral of yc dA is, well, substitute in our definition of y sub c, so that becomes kx squared over 2, and then we got the area of this rectangle, which is y high, and y is given to us by kx squared, so we have another kx squared times its width dx, and that would be, in this specific case, k squared x to the 4th over 2 times dx, and then we can go on from there. We know that this function is add a coordinate pair of AH out here at this point. So with that, we would be able to figure out that K is equal to A over A squared. You can substitute that in, away you go, blah, 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 blah. We're integrating along with dx, so that would go from d0 to A, etc., etc., etc. Right? Now, everything else from there is just more complicated, but it's the same overall approach to how we do things.